Hello, hello. Wow, it has been a long time since I've streamed, and I have no viewers. Hello, hello. Current viewers 1, which is me. Haha, how novel. Let's start with the plan. Google Docs. Let's create a blank document. And let me pause the stream as I get my laptop charger. In game. I should probably assign a hotkey for that, shouldn't I? Right, we gotta make a plan. So, what we want to do is we want to make a. Alright, what I'm doing is I'm creating a 3D print. A 3D printable tripod mount for a S20. I want to make a 3D printable tripod mount for a Samsung S20. Okay. The criteria for that would be how do I make bullet points? Bullet point. Oop. I don't know how to make bullet points. Let's just. Oh wait, here, found them. Found the bullet points. I don't want a bullet point there. Fuck it. Let's go. Criteria. It must have. So the criteria, I want it to have articulation. I want to film painting minis for this channel. So, the YouTube channel, not the Twitch. Well, they'll be on the Twitch since I'll stream it and then chop it into digestible YouTube videos. But besides that point, it needs to have 3 points of articulation. A X and a Y axis on the arm, and a pitch and yaw axis on the camera. So X, Y, and pitch and yaw. X and Y articulation and pitch and yaw, which, if you don't know what X and Y articulation is, and I assume most of you played Minecraft, is I want it to move up and down and left and right, which will basically give me 360 movement, except my camera won't be 360. It can only move, it would only be able to move left and right and up and down on a vertical plane. With pitch and yaw, it can move forwards and backwards. Enough of that technical talk. That was a little a little nerdy, I guess. It's got to be stable. I have to go research the stability triangle, of course. As long as my phone stays in the stability triangle, and I want to be sure that I have a good size stability. Let me describe the stability triangle in a more word. So if you look at forklifts, if you look at the world of forklifts, what is a stability triangle? Basically, as long as this ball stays in the stability triangle, it can move anywhere in the stability triangle. This ball is the center of mass. It can move anywhere in the stability triangle. It will not fall over. But if it moves out of the stability triangle, it will fall over. So what I need to do for the stability triangle is I need to have quite a large one to allow my phone to move in truly any direction that I would like to film in. Now, why am I not using a camcorder and I'm using my phone? I don't have a camcorder. That's why. And also, I would assume most of you don't have proper recording quality cameras, and you want a decent tripod mount you can 3D print. So, I will go back to here, stable center of gravity. Articulation, pitch and yaw, stable center of gravity. I want it to look cool. Now how am I going to do this? I'm going to do this by, looks cool, of course. I'm going to do this by, oh shit. Of my phone. I'll do this by finding out the weight of my phone. Finding out. Oh, forgot the most obvious. S20. Now here's the thing. I don't know if I want to have it just mount the S20 or all phones. Now, I'm thinking about something to do with elastics. With all phones having like slots in it, so it pushes like the bricks on the phones so you can size it. Because I'm going to get different cases for my phone, and I'm not always going to have an S20. I will probably upgrade my phone at some point. Okay. However, making this adaptable for all phones, not just the S20, means the stability thing will be a problem, and I think I know how I'm going to deal with that. Let's go into Tinkercad and start making ideas. Um, so I'm thinking, let's just start simple. How big is this? Millimeters. 60 watts. Can I get a ruler? This ruler's vague. Edit grid. Millimeters. Okay, the units are millimeters. That's good. We're using the scientific ones. Uh, 20 size. D triangle. Stability, because the stability triangle effect was apparent, keep the lift stroke stable and center must stay in the pyramid. If it moves outside the pyramid, that's what I already know. I want to know how to calculate. How to... Multiply each object's distance from the datum by its weight and find the moment. This gives you a moment for each. Add up the 3 moments simply to the math. 240 feet times, okay. And add the weights of all the objects. Find the sum of all the weights. Divide the total. Yeah, fuck this, I'm just looking up a calculator. Center of gravity calculator. Easy. Oh. No, this is just more maths. I'm not the biggest math nerd. In fact, I actively try to avoid math, and I don't like thinking about it. Friction will be a problem. We have a mount to attach on the table, but I don't think that would be the best solution. So, because it'll be slippy and slidey. Group these. The Samsung is 20 size. Size of weight. So there's a height of 500 millimeters and a depth of 7.6 millimeters. Yeah, I also have a width of 69.1 millimeters. I feel like that one was intentional. Samsung. All right. So I'm going to play it safe and have the base double that. Because in my mind, the base, instead of doing all that boring math, because I'm sure that'd be fun for you to see me try and struggle through the math, I'm just going to have the base twice the size as the phone's articulation. And I'm going with a I have two ideas. I could go with a triangle base. Triangles are nice. I can save on filament and size. Or I can go for the square. Let's see what a square gets me. I might change this. I might change this. You know, people watch Minecraft and play so much Minecraft. I wonder why more people don't like get into 3D design, because it's basically like Minecraft or like Lego. It's really okay. I'm I'm novice level 3D designing in Tinkercad, but like get into it just to see. I'm not the best 3D designer. I'm not even a good 3D designer, but I've done simple things before. I've made products in 3D. I have I've made a car before. Not a on the road car. I made a little remote control car before in Tinkercad, and I thought that like that's enough for me to see. I could probably build most mechanical things in here. Functional, not elegant. Shape. I've got a square. What's my square's diameters? It's actually a rectangle because I didn't build a perfect square. What's my square's diameter? Or not diameter. That's a circle. What's my square's area? 69 by 60. What's a height of 1.57. So give mine a height of 1.17. Millimeters, right? Yep. So this is my phone represented in Tinkercad. Let's just do 1,000 by 1,000. There. Way bigger grid. So this is about the size of my phone. Really? Only allows you to use 220 millimeters of print surface. However, Createlli is from an old and more basic version. The official firmware. Okay, so my Ender 3 reaction pen. I have this on my Ender 3. The paper clips to keep the. Yeah, okay. So the max build space for my Ender 3 is 220. I'm just going to go a little bit short of that because I have some monstrous rafting going on with my Ender 3. That can't be right. One sec. I I just brought a ruler up to my Ender 3. That is completely right. Um, right. So 200 is this. This is the maximum width I can do. Uh, uh, 138. 138. I just realized something. I can make an equidistant box like this at 200 meters times 200 meters and millimeters. Probably don't want too much depth. 5 millimeters. Wait a minute, was that it? Oh, that's spacing in the real world. I don't care too much about that. Probably about 5 millimeters would be good, just enough to have some. You know what? Let's make it thicker. So we have it 12 millimeters. We just have this flat plate. This will be expensive to 3D print. Let's cut away in the center. I was about to say that will solve our friction problem, but that's what she said. I'm immature. That would solve our friction problem. But it'll also be expensive to print, which we don't want. $175 by $175. 52. That's not how you use a ruler correctly, is it? No, it's not. Because now they have the exact same corner. I don't want that. I want 175. Half of 25 millimeters would be simple math, 12.5 millimeters. As a physical representation, what is 12.5 millimeters long? Uh, hmm. 12.5 millimeters for my Americans is 1 1/3 9mm shells. So 12.5 millimeters for my Americans is 1 1/3 9mm shells. That took me shells, not shells, bullets. 12.5 millimeters is 1 1/3 9mm bullets. So the number I want to put here is 12.5. No, that is not the number I want to put here. The number I want to put here is adding 12.5 to 64.5. And this, I'm going to add 12.5 too. That's not correct. This has to have his own calculation, which should be the exact same as this one. 6, 7. 17.5 should be the exact center. Oh, it is. I'm just dumb. Just put a hole in the middle. There we go. Watching a grown-ass man struggle with simple maths. Should probably write this down. 64.50 is 64.50 and 17.50 by 17.50. Right. Let's put this block in the exact center. $4.50. Right, that wouldn't be the center, that'd be the corner. Center would be a different calculation. That's fine, I want it on a diagonal. I want it at 90 degrees of straight up and down. Want it at... Oh, that wasn't the angle change. Believe 45-degree angle. Yes. I want to not size it up. Why can't I just build... Gesundheit! Why can't I just build at an angle? I want to just expand it this direction. We can round this slightly because it's not going to be... Actually, we could round all of this. Too late! Should have rounded it before. Okay. Putting feet on all the corners. I'll probably just do that with either blue tack, rubber feet like you get for your coffee tables. I don't know. I'll figure that out in the build video where I record me actually assembling and implementing this. I want to 200 millimeters. Should be 100. Put this at a 45-degree angle. Wait, from corner to corner it'd be 100 degrees, wouldn't it? Not 100 degrees, 100 or 200. This should be 200. This should not be slanted whatsoever. Why is it slanted? Unslant. Deslant, sir. Sir, deslant for me. Why are you slanted? Unslant. How did I mess you up that bad? Box. Okay, box. Height. 200. Shape. Radius. I want you slightly round. Edges. Steps. This is just how many until it gets round. Length. Okay, I'm just going to add that. So box, length, 200. Width, 12.5. Height, how tall is this? Height, 12. .45-degree angle. Why? All right. That's correct. So I've been thinking about how we're going to do the articulation. Oh, right. I'll just keep it square. It's easy for the 3D printer, so it'll print quickly. Might as well have some fun, since I wanted it thick so I could put some text there. I will thicken it up, shrink, shrink. Shrink! Smaller! Text. What this should do is it should put a hole right in it. Let's test that, though. Sweet. We put a hole right in it. Though I want this a little higher. I fucked it up. Higher. Need to make it a little smaller. A little flatter, actually, not smaller. You gotta keep in mind, there's a good chance stuff like this in the bottom will break, because this is probably only a few millimeters. Like, this is only 12 millimeters thick. That's probably only like half a millimeter thick. Like, there's a good chance that this bottom part won't even print where this L is. And I'm worried about that. But I think it will. But you gotta remember, this is absolutely tiny. Oh, and I'm sizing up for the Ender 3 because it's not only the printer that I own, it's also the most common printer on the market. It's the most affordable. And I'm trying to keep with relative simple shapes. Let's keep this more round. What's the Ender 3's maximum height? It shouldn't matter because of how I'm building this mount. Uh, 220 by 220. I'll keep the size of this one print up down to 220. You won't be able to print this in one go. So I'm going to keep this relatively thick, 20 millimeters by 20 millimeters. That's about the size of a... That's about the size... That's slightly smaller than a toy soldier. Let's now look at the home hardware website. How to shop local. Home hardware. Products. Appliance, kitchen, pay, tools and accessories. Tools and accessories. I'm just going to look it up. Nut. And bolt. Fuck. Bolt. Bolt size. Bolt. Nut. And bolt. Nut and bolt. Amazon. Bolts and nuts. Not logged in. Good. Sure. Hex bolt and washer. $14 on Amazon. And let's size it. Let's size it for these. Seems like 12 millimeters is pretty standard. Right, we're sizing it for a 12 millimeter hex bolt. Here's the Amazon. This is an. Can I get an affiliate link? No. Okay. It's on Amazon. You can buy it. I just need to know it for sizing. Oh, that does mean this needs to be 12 millimeters thin. Actually, needs to be less than 12 millimeters thin because you need to fit the bolt on. So I'm going to make it 10 millimeters thin. And oh, that doesn't look nice anymore. I'll clean it up. Turn my snap grid off. Can I get away at that? I don't think so. Okay, we're good. I'm going to shorten this. What's it at? What's its height? 136. More like 100. That's not the correct thing. $150. 150 millimeters is, I believe, where's the S20? Samsung S20, 151 millimeters. We will not have enough clearance for the S20 to be folded in and sideways. So it needs to be that much bigger. That was just a random number. Okay. $12. What's the hex bolt? I'm going to need a little bit of clearance. Amazon. 12 millimeters. Actually, no. I don't think I want clearance because if I have it fresh, I can basically force the hex bolt in. Like I can bevel it a little bit. I want to bevel it the other way. I want to explode it. Like, I want to bevel it out. I'll just leave it flat as it is. Simple, don't over-engineer. Most things, when you over-engineer them, fail. Okay? Put it at a 90-degree angle. There we go. Up. Through. Okay, it's gone through. Control G. So what you'll do is you'll stick your nut through the hole. Tighten it, and then you'll have back and forth. Control Z, Control Z, Control Z. Control C, Control V. I need this part. The rest of you can group back up. Actually going to ungroup the whole thing. And I'm going to round all the edges. I'm going to ungroup the whole thing, and I'm going to round all the edges. Shape. Wait. Ungroup. There we go. Shapes. I ungrouped everything. Ungroup. Everything. Are you ungrouped? Good. I'm going to take this. Shape. Radius. Two. Let's group them all up again. See how it looks. Where did... Okay, so take everything, ungroup. Take this piece and give it a radius of 2. Take this piece and delete it. Take this piece. Actually, I want to see what it looks like with the internal. Rounded. So it's still square, but it's internal rounded. Honestly, I like the other way better. I know what happened to the piece. Because I regrouped it, I put the thing in after. I gotta group my square in before I group my everything else. 2. So I got to take this. I got to take this. Shift, take this, and group the two. Then I got to group everything. Okay, there's a pitch. And so far, I don't know this to be true, but as long as you keep the phone within the square, it shouldn't tip over. But that's only in the theoretical. And I want to allow for mounting with like tape or something, where you can just tape it down. I want to ungroup these guys. Where you can just tape it down and you can move it forever, or move it in any direction. I don't know. I think taping it down will probably be the best bet. I want this piece. Group these guys back up. Control V. I want this piece. Oh. 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 That's not the length of the nut. That's the diameter. That's its thread size. It's 18 millimeters long. That's wrong. No chat still. That's just plain wrong. Oops. Okay. Let's refresh this. And let's think further. Okay, so 18 millimeters in width. Combine 18 millimeters of width. What is the width of this one? I made it 5. No, wait, no, that's its. Ungroup. What is the width of this? It's 10. Okay. So this will have to be 8. This will be just a small segment. With a diameter of 12. Did I mention I don't really know what I'm doing? I'm just kind of trying to build something, and we're going to fail multiple times. And it's going to work eventually, after we fail enough times. It's called failing forwards. I wonder how you, how do I check chat? Can I do it on my phone? Can I check chat on my phone? Phone. I have no chat. Okay then. I have no chat. I'm going to tilt you at a 90-degree angle. Oh, you can hear that. Turn my volume down so you can't hear my phone. And Control G. Group. This will be simple. We'll just have this twist. Twist. 90 degrees. Then we will flip it 90 degrees. And have it, oh, we will flip it 90, we will flip it. We will flip it. Thank you, Tinkercad. 90 degrees. Let's make this look nice. Rotate. Rotate. I'm going to add bevels, but not with the bevel tool. I'm going to just cut into it. Kind of looks like a face. This was a weird design choice. You know what? I'm just gonna cut away the excess. Yeah. It's probably not the most entertaining content, but I don't care. I'm enjoying myself. That's all that matters. That, and I'm building you guys some of you better be grateful, you ungrateful bastards. Control C, Control V. This is probably really bad for the algorithm. Oh, Control Z. Talk about something. Talk about something besides what I'm doing. Or talk about what I'm doing. Gaming channels do that all the time. Except theirs is more interesting than moving blocks around. Okay. That looks like a thing. Okay, so we now got up and down. Ungroup. We now got left and right. Let me copy another one of these pieces. So, I should probably talk about, seeing this is my first video, why I'm creating a channel like this. I'm watching all these build channels on YouTube, and really while watching all these build channels, I'm seeing that there's nothing really you can build. I want to make things that the average person with almost no skill could make on their own. So if you were me, you could make on your own. So up, down. Now we need the pivoting. We need the pivoting, and I know exactly how to do it. Connectors. Ball. Ball connector scales with 3D printability. Use these parts to create your own posable kits. Rotate as needed. Okay, well I needed this at a 90-degree angle. I don't know if this ball joint will be strong enough. I actually need it at that angle. I really hope this ball joint is strong enough. And time for the final bit. Basic shapes. A box. That is 157 meters long. The length of my phone. $15 meters thick. About approximate length. I believe it's 151. And 69.1. It's about the size of your phone, or my phone. Now, here's my idea for making it all phone compatible. Just add a slit right in the middle. I'm getting tired. Where's my energy drink? Just add a slit right in the middle for an elastic band. Put that on either side. I'm gonna need a post for that, aren't I? Basic shapes, connectors. Socket. Sockets get through printable. Use these to create your own puzzleable kits. Is this socket for the ball joint? Oh no, I'm probably gonna want a support socket, aren't I? Yeah, I'm gonna want a support socket. Because the weight of my phone probably will be too heavy for the friction. I ought to turn this sideways though. 90 degrees. There we go. Juicy. Nope, that's not correct. That's wrong. $90. Wait, so this is up and down. This would be forwards. This ball socket will be goes up, down. Believe the ball socket needs to be like this. I can make an edit if it doesn't. How tall is this block? 54. Let's make it 60. Control C, Control V. Do the exact same thing on the other side. Is this flush? Yeah, it's flush. Okay, up, down, up, down, up, down, up, down. Up, down, up, down, up, down, up, down. What else? I'm gonna want a cup. This sounds weird, but I'm gonna want a cup at the bottom. Make that uneven. Okay. I'm getting tired. It's 12. Basic shapes. $13 thick. So because no one's gonna trust this with their phone, some elastic bands, not even me. And I built the fucking thing. Build a cylinder to hold the phone. What is the depth of a S20? Depth of 7.6 millimeters. So as long as it's more than that, we're gooch. It's 20 millimeters thick. 22 millimeters thick. Cylinder. Radius of 17 by 17. This will fit the S20 perfectly, but nothing else. Ooh. That could be a problem. Let's bevel this. Just to make it look pretty. So here's what we got so far. Control G. And these next parts will be easy, and then we'll be done. An entire 3D print from start till finish. Done. What is the width of this object? The width is 50. Which means to look proper, your width will be 50. And I believe I kept the height as 20.3. So your height will be 20. If we are going to use the elastic band method, this spot in the middle is going to have to be slightly cut into in order to support the elastic bands. Or not support the elastic bands, but not push the phone out of the case. Locked up like that. Great. So now we make this thing. Copy. We got two of these thingies now. Really? This is why I always extend them slightly bigger than what they're supposed to be. Okay, good. Control G. We're good. We can try to start printing now, and I can check my OBS. There is no chat. We've been streaming for an hour and a half. Huh. Okay. Let's check the YouTube. Let's check the YouTube chat. See if there's anything in there. Maybe next time we stream we should have some music, because I bet that was boring. And got something from idea to design in just an hour and a half. Now to start 3D printing. I'm really sorry for this. We open up my very messy desktop and go into Kira. Ultimaker Kira. Export. STL. I want to test the ball joint first. So, testing the ball joint. Control C. Oh, Control C. Control Shift. Control. I need 2 of these. Control C, Control V. All of this will be in a file on Thingiverse. It's one of the sites. It will be linked in the description of the YouTube video. That is coming out very soon for this. Export. Only 450 STL. This is the part I want to test. This is the part I'm worried about. Let's see how this works. Bobacious Goro. Come on, Kira. Let's browse Tinkercad. Or Thingiverse. Is there a create? No, upload a thing. Sign up. Tile key holder. This shit's cool. This shit's cooler than mine. Mine was built to be functional. Yeah. That's about it. Mine was made to be functional. I bet you I can find a 12mm bolt. I bet you're going to even find a 12mm bolt in here. A guillotine, a spring-loaded replicator. This shit's cool. Compact SD card adapter. Access. Printing other 3D printers. This is giving me ideas. I think for another design, I want to build a wallet. After, obviously, we R&D and test this design. This wallet is really, it's fashionable, and I need a new wallet. I kind of like this, this whole strap design. I'll see what I can do. I might look at something like this. Maybe a Pez dispenser type thing. Maybe put some spacers. I love these carabiner design. With this whole shape. I don't know how strong the carabiner would be, but I like that carabiner design. See, a lot of this is art and design. And I want to implement some art and design, but I don't know how to do that in a short format. I want my things to be functional. I guess that will just come with skill level. Did Kira open up? Yeah, Kira opened up. My Bodacious Goro. Is too big for my printer! Haha! Yeah, that's thick anyways. Let's thin these up. 17. Let's do it 12.9. 12 seems like a good number. I've been using it for pretty much everything. Leave that there, leave that there, leave that there. So let's just export. TL. I don't want to stop exporting. Okay. Caps lock off. Phone holder main. Fold holder main. I want to open up. I closed Kira. Kira Ultimaker. I want to make a new folder. Get phone holder main. And the attachment point. Those are the two parts I want to print because I want to test their functionality. I'll then print the other parts, export, STL, move that to the side. Phone tripod. Copy. It's very simple geometry, should allow faster prints. day. Darn. Ah, infill density. $21 hours. Extruder. Okay. 21 hours, 18 minutes. This will be a long print. There'll be a video when I've fully assembled this, and there will be recordings of whatever. I'm gonna go now. Bye-bye. I hope you absolutely enjoyed this.